This lesson is going to begin our study of right triangles. The essential questions for this first lesson are, what is the geometric mean, and what are the relationships that exist when the altitude is drawn to the hypotenuse of a right triangle? So the first thing we're going to talk about is geometric mean. Most of you should be familiar with what we mean by arithmetic mean, where you simply add up the numbers and divide by the number of numbers, okay? The geometric mean is something a little different. So let's say I have two positive numbers, a and b. Then if I were to write the proportion a over x is equal to x over b, x would be called the geometric mean between a and b. Or more specifically, x would equal the square root of a times b. So therefore, if I had any two numbers, say 5 and 11, and I wanted to know the geometric mean between 5 and 11, I would simply say that the geometric mean is equal to the square root of 5 times 11, or the square root of 55. So now let's talk about right triangles. To start off with, we have a theorem, and this is Theorem 8-1 in your textbook. And this theorem says that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So let's look at our diagram here. We have a right triangle ABC, and we're drawing an altitude from A to point D, which is on the hypotenuse, okay? Now, we have three triangles here. We have a triangle on the left, ABD. We have a triangle on the right, let's see, CAD, and we also have the original triangle, which is CBA. All three of those triangles are indeed similar, and that is exactly what this theorem is saying. Now, this theorem leads immediately to two corollaries, which from now on in this course we will refer to them as Corollary 1 and Corollary 2. Now, Corollary 1 states, when the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. Or, to put it in the form of a proportion, you could say the length n divided by h is equal to the length h divided by the length m. So n over h is equal to h over m. Or as the corollary states, h is the geometric mean between n and m. Now corollary 2 states the following. When the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to that leg. In other words, this corollary is going to have two parts. Now, the first part of this corollary can be restated in a proportion as the length of the full hypotenuse, in other words, lowercase a, is to lowercase c, which is the one leg of the right triangle, as the length lowercase c is to the segment of the hypotenuse closest to that segment c. So a over c is equal to c over n. Now the second part of this second corollary can simply be written as a over b is equal to b over m. Or in other words, the length of the full hypotenuse is to the leg b, the length of the leg that's lowercase b, as the length of that leg, lowercase b, is to the segment of the hypotenuse that is closest to b. So a over b is equal to b over m. Now I'd like you to go to page 288, the classroom exercises, do problem number 17. There's 3 parts to it, A, B, and C, and post your answers in the drop box. Thank you.